Hello, everyone. So today we're going to talk about a vital force in the renewable energy space known as biodiesel. We'll be looking at what it is, how it's made, and what its true impact on our environment and economy is. So, what is biodiesel? At its core, it's a renewable biodegradable fuel made from a mix of sources like vegetable oils, animal fats, or even recycled cooking grease. Unlike standard petroleum diesel, it's non toxic and produced domestically. You'll most often find it in blends like B5, which is 5% biodiesel, or B20, 20% biodiesel, which can be used in most diesel engines without any modifications necessary. So the bio part of biodiesel comes from biological sources. The most common or first generation feedstocks are agricultural crops, primarily soybeans and canola. But this has sparked the important food versus fuel debate. Should we use cropland for fuel instead of food? So this is why second generation feedstocks like waste vegetable oil and third generation feedstocks like algae are so critical, because they don't compete with our food supply. So to understand why it's renewable, we have to look at the plant science. This is where photosynthesis comes in. So the feedstock crops like soybeans absorb carbon dioxide from the atmosphere and use sunlight to convert it into energy known as glucose, which they use to grow and produce oils. This process of capturing carbon is what makes the fuel's life cycle so much cleaner than fossil fuels, which only release carbon. Now, how do we get from a soybean to fuel? It's important to know that biodiesel is not made through fermentation like ethanol. Biodiesel is actually made through a chemical process called transesterification. So, in this process, the oil or fat that we're using as our source is reacted with a short chain alcohol like methanol and then a catalyst. So, this reaction breaks the oil down, producing two main products. The first is biodiesel, which is technically called a fatty acid methyl ester or FAME, and a byproduct known as glycerin, which is then used in soaps and other everyday products. And so this diagram kind of shows a little bit of that process. So, is this fuel a fuel of the future, or is it kind of here and now? It is absolutely widely deployed and available. As I mentioned, B5 and B20 blends are going to be the most common that we see at pumps across the country, and fully compatible with existing engines. A little bit less common of a mixture is going to be B100, which is also available for specially modified engines. The main research and development today is focused on making those advanced feedstocks like algae commercially viable options to get past the food versus fuel hurdle. So this is where biodiesel truly shines. On average, biodiesel shows a 50 to 80% reduction in life cycle greenhouse gas emissions compared to petroleum diesel. It is considered a near carbon neutral because the carbon released when it's burned is roughly equivalent to the carbon the plant absorbed while it was growing. And it also burns much cleaner, which drastically cuts down on particulate matter, carbon monoxide, and sulfur. Um, the economic impact is also a significant point to mention. The biodiesel industry supports over 75,000 jobs in the US and contributes over $23 billion in economic activity, from the farmers in the field to the workers in the processing plants and kind of everywhere in between. It also strengthens our energy security by reducing our dependence on foreign oil as well. So you've probably seen communication efforts without even realizing it. In the US, the Renewable Fuel Standard, or RFS, is a government program that mandates the blending of biofuels, which creates a stable market. Industry groups like the Clean Fuels Alliance America run campaigns to promote the benefits of these biofuels. And at the consumer level, you have a clear labeling on diesel pumps like B5 or B20 to inform the customer of kind of what's going inside to the engine. So my analysis is that biodiesel is a proven, mature, and effective transitional fuel. It's one of the best tools we have right now to decarbonize heavy transport. Its primary challenge is the reliance on food-based feedstocks. So therefore, my recommendation is simple. We must aggressively prioritize research, development, and policy to shift production to non-food feedstocks like waste oil and algae. If funding weren't an obstacle, the first thing we should do is mandate the global scale collection and conversion of 100% of waste cooking oil. Second, we would invest massively to scale up third generation algae bioreactors, turning them from a research project into kind of an industrial reality. And then third, we would build out the dedicated infrastructure and R&D centers to support this new, truly sustainable supply chain. Thank you so much for your time. And if you have any questions, please let me know.